keep doing the problems from Halliday, Resnick and Walker, chapter 28. Problem number 3, it's an easy one, okay, because we just need to apply this well-known formula here. And to be honest, guys, this is pretty basic because they gave us the velocity vector, they gave us the magnet vector, the magnet field vector. So the only thing that we need to deal here with is the matrix, right? So, and well, so let's see what's going to happen. So we have the force here. How we calculate the force? It's going to be Q, V, cross product of B. But I just need to highlight something here. This formula is just for particles. When we have a wire, this is going to be chapter 29. Agreed? So we're going to deal with that. It's a completely different problem. Okay? So this is when we have particles. That means ions, cations, or protons, something like electrons in this case. Cool? Let's go. So the way that we're going to do that, I will do something like this. Look, my magnet field vector, okay, will be the charge. And let's start our matrix here. Okay, so everybody here, hat, I hat, J hat, K hat, and let's plug it in here. But first, let me do something here, guys. Let me put the raw material here. Okay, so I know that I have a Vx vector, Vy vector, Vz vector. Agreed? So I know as well that I have a Bx vector, By vector, Bz vector. So you can do this problem this way. If you foresee that this guy here will be ending up only in K direction, this is going to be, you can just eliminate these guys here because you're going to need to use the K. If you do the right hand rule, remember, the right hand rule will give you, take a look. If you have, for example, this will be the Y, this will be the J, and this one here will be the K. Hat, hat, hat. So you know that if you do IJ, we're going to end up K, this is going to be positive or negative, either way, okay? So you know that the velocity here is I and J, okay? And the magnet field is I and J. So the only possible directions that we have here will be positive K or negative K. Do you agree with that, guys? So you can, if you are in a hurry, you can just see like, okay, so I just need to be concerned about my K direction here. Okay, so, but because this, you can use this problem here as a standard for the other problems. Let's keep going with this one here. Okay, so but if you know already that's going to be just the K, jump the video, go to the part where they start to do all the rest. But let's keep going here. Okay, so here we're going to have K and the matrix, so it's going to be A here. Let me do step by step. So it's going to be just this part, and let's keep going with this. So I will put here in a color, in a certain color here, it's going to be Vy, Bz. By the way, we're going to do positive, negative, and positive, okay? So Vy, Bz, these guys, and minus Vz, By. If you did understand why we have only K, you can understand in a few steps. So now minus, right? Minus, and then let's make this color. Let's put a lot of colors here. So take a look now. If you go this one here, okay, this one, so what you're gonna do is, oh, okay, so you see I'm getting even better now with my colored inks. So take a look. we got here Vx and Bz, so Vx times Bz, okay, and minus Vz Bx. Agreed? Pretty basic, right? And this guy here will be J, okay? So now we're going to do plus sign, and we're going to do here our third version. Okay, so I just need to clean up this guy, and let's keep going up. Okay, so it's going to be Vx Vy minus Vy Bx. Okay, and this will be the end of the matrix. Now take a I forgot to put something here. Let me just plug this guy here. This is gonna be I just need to put K here. Okay, K hat here. Okay. So now what we need to do is let's analyze this expression here. So I don't have any z component here, any z component here in B as well. So BZ, 0. VZ, 0. BZ, 0. VZ, 0. Now I have Vx, By, yes I do. Vy, Bx, yes I do. So the only one that is not equals to 0 is going to be the last one, that's K. Okay, so let's keep going. So now FB, so it's going to be my force, will be the charge of this guy times what? Vx, By minus Vy, Bx, direction K. Right? So we just need to plug it in the numbers here. So when we plug it in the numbers, we're going to get FB. And we are dealing with electrons, right? So if you remember, the charge of electron, the electron charge will be negative, right? Negative 1.602 times 10 minus 19 coulombs. Okay? So if we are dealing with only electrons, this is going to be the charge. So I just need to put here minus 1.602 times 10 minus 19 coulombs. Okay, so this is going to be my first one here. Now, second one here, Vx. So for Vx, I have, I can just put a bracket here. So it's going to be Vx going to be 2.0 times 10, 6 meters per second, right? And this will be the Vx, now By. By will be 0.15 Teslas, okay? And minus Vy, so it's going to be 3.0 times 10, 6 meters per second square, sorry, and multiplying by Bx. Bx is going to be 0.030 Tesla. Is that right? Yes. Is that right? Okay. So what we know about these guys here? I know that this number here will end up with negative because, why negative? Because this guy here is negative. Take a look. Okay, so this guy here will be negative. So my number here will end up negative 3.0 times 10, 5 Tesla meters per second. And this guy here will be 9 times 10 4 meters per second and Tesla. Okay, so when I do all the multiplications here, this guy here will be ending negative because this guy here is bigger than this one, but I have another negative number here. So my final number for force here, it will be positive 6.25 times 10 minus 14 newtons. And this will be in K, the positive direction of K. So it's going to be in this direction here, okay? So the force will be for this direction for an electron. Now, if we are talking about, so the next item here is repeat your calculation for a proton having the same velocity. So if we do everything here, we just need to use the same mindset, guys. It's the same mindset. The only difference will be here, because for electron, the charge is negative. But for the proton, if you're going to use the proton for the charge, it's going to be 1.602 times 10 minus 19 coulombs. So this is going to be positive. And when I have this guy here positive, I do all this stuff because this will not change for proton. And for this is for electron. Okay, this is for electron. For proton, what we're going to have will be the same number, but will be negative. Okay, so 25, 10 minus 14, and newtons in the negative direction of this is for proton of K, right? So this was the one easy. It took a little bit longer because I was showing you guys this part here. But if you see the problem, if you see only I directions here, J directions here for velocity, and the same thing for magnet field. If I have only I and J's, it's clear that our direction will be in K for K direction. I mean for only Z direction. So it's going to be only the difference can be only positive or negative. Okay, so I hope you guys practice a little bit this one, and keep in mind that this is the rule that you need to use every time when you have a charge. Remember, this formula here is for charges, okay, not for wires. Okay, see you in a few minutes.